Thank you for joining this webinar. As always, I'm presenting from within Displayr as it's designed for interactive presentations. But everything I show can be done in Q as well. So if you're a Q user and there are bits you want me to show you in Q, just tell me and I'll get through to them at the end of the webinar. How do you tell me? Well, there's a questions field in GoToWebinar, a little app that you'll have on your screen. Just type it into that. This webinar starts where the previous webinar finished. So if you haven't seen the beginner's guide, I suggest you watch it first. Unless you're an expert, then there will be no need. In this webinar, we'll be digging into two broad themes. How can we efficiently work out what's changed? And how do we explain why measures have changed? We'll kick off with some great small multiple visualizations that are designed to help us to quickly see what's going on in the market. So here's a table. It's showing frequency of buying different burger brands over time. What's going on? I'll give you 5 seconds to see how good you are at interpreting tracking tables. If you're an old hand at trackers, you'll have jumped to the column at the end and you'll have noticed that the only thing that moved was Arnold's. It went up from 1.5 to 1.8 times ordered in the last month. Now, I want you to remember this difference, 1.5 to 1.8, a difference of 0.3, because we're going to explore it a little bit later. But how can we visualize this? This is how I like to visualize this type of data, and if you want to do it in Q, the instructions are shown here on the top of the page. Now, you can clearly see that Arnold's is by far the biggest of the brands in terms of the average consumption. This column is actually showing across the total sample. I'm going to change it to just make it look at the last quarter, and it's automatically put the significance test comparing it to the previous quarter. So we've got that same key result we got from the table. The thing we've got added though is we've got trend lines at the bottom. Each trend line shows us the long-term trend for the brand. And so we can see that while Arnold's did go up, its long-term trend is one of decline. And we can see that it's only some of these smaller brands which have got growth happening for them in the long-term trend. But that was actually a pretty easy example. Let's now look at a much harder one. This table here looks like a big table. It's the various fast food brands by some attributes. But look, there's a scroll bar at the bottom. I've actually got 21 different attributes. That's a lot of data. I've got 27 months. Let's cross tab. So now we're going to have a table with 567 columns. We could spend a day trying to figure out what all of this means, or we could just use a visualization. Again, this one is in Q. Now, Arnold's is the brand we're focused on, remember. Red means declining long-term trend, blue means growth in the long term. If we read across the Arnold's line, we can see, okay, long-term they're losing in terms of value, drinks, cleanliness, decor, design. So now we're starting to form a theory about how the Arnold's market is working. But that's the long term over almost 3 years of data. We've seen that the last quarter went up. What's our last trend for the 6 months we've just had? Excuse that mangled sentence. I'm going to choose month. We'll do a little filter here. Let's have a look at 6 months. And so very quickly we can see that within the data we are seeing a good news story, which is that it's done well in drinks. And you'll remember this is one of the things that was going down with long term. So that suggests that the company's dealt with the issue. And we can see that the rest of that upsurge seems to be driven by opening hours, fast drive-through and easy drive-through. So like a convenience play. Now, one of the questions that I get asked quite a lot is, when you test for trend, how do you actually test for trend? And the background to this is most market research, stat testing involves comparing columns in a table. How do you do a trend? Well, what we'll do is we'll drag across the variables which show frequency of ordering in the last month. Now,
If I dragged across my month variable, I get a column for every month. So what I'm going to instead do is I'm going to duplicate it in QWorld. That's just copy and paste, exact copy. And I'm going to change the structure from date and time to numeric, because the table we're currently looking at, where the frequency data is numeric, this is numeric. So if we cross one by the other, Displayr and Q will show us correlations. And so these are in fact the significant test results we saw at the bottom of that earliest visualization. Now, as I'm sure some of you are talking to the screen and saying, yeah, but that's assuming a linear trend. What if I want to understand a non-linear trend? Well, to do that, we need to use something called a spline with a simultaneous confidence interval. If you can't find it in both of our products, just type the search box at the top, and it'll guide us through. Now, we can only look at one variable at a time with this. You see it's actually quite slow. It's going to do some really, really complicated number crunching. So what we're going to do is we'll expand out this Q5A, which has got all of this data, and I'm just going to right click on Arnold's and I'll just duplicate it. So I've got an extra version of it, and I'll just release that as the outcome. And now I've got to choose my predictors, and my predictor is going to be my month data. Now, a little trap for beginners here. It says regression type binary logic. I'm just going to change that to linear because we do want a linear regression because we've got a linear outcome variable. We get a little warning here because it's an enormous calculation that's been done here. It's really complex math. Now, when we look at it, the black line is showing us our best estimate based on the available data of what's going on. And our best estimate is that the long-term trend is decline, and there's a little bit of evidence for a weak uplift towards the end, which is what we saw from that statistical tests. But we've got fairly large confidence bands around that uptick, so you would be brave to assume that we've 100% for sure improved things in the last quarter. Yes, this is contradictory to the traditional statistical test, and this is kind of one of the challenges with all tracking research. You do get inconsistencies from time to time in different ways of looking at the data. What should we do here? Well, we would want to look at what other data is available than our survey to see if we can corroborate whether the brand did indeed have an increase over the last 3 months or not. It's the advanced tracking webinar, so I'm not going to give you an easy solution. Sometimes you just get contradictions. A question that came up in the previous webinar, and I should mention, I've discovered that we haven't actually sent out our follow-ups to the previous webinar, so they have been written and they will come out with this webinar's follow-ups. Question we had in the last one was, how do you do a seasonal decomposition if you want to remove seasonality from the data? Now, I will walk you through this, but I will just say it's not a technique that I've ever really needed to use in my consulting career. It's one of these business school techniques which tends not to work so well with market research. When I say it doesn't work so well, it's because in market research, if we did have multiple years of data, we'd often just look at it annually to see the trend rather than try and pull out the seasonality. But if you want to do it, this is how we do it. So I've got here a table showing me a whole lot of beer sales data. I haven't used any of my surveys because you need at least 3 or 4 years to do a good decomposition. Now I'm going to click on this because we're going to do this using a small amount of code. At the moment, that plot we were looking at was just done by running plot and then the name of my beer consumption data. To do the decomposition, I'm going to write decompose. I'm going to tell it that I need to have a type of something called multiplicative. And I've got to close my parentheses at the end. Oops. Now, multiplicative just means that I assume that if my sales double, the seasonality effect doubles as well, which is a reasonable assumption, but bad English again. So again, sorry. So now we've got the little output here, and we can see here, showing here is the trend once the seasonality and the noise are removed, and that's a much clearer picture. And so if we wanted to look at, in this case, quarterly data without seasonality, this is certainly a better view of the data than the one we had above. This next topic is a quite advanced topic. We talked in the beginners webinar about the need to weight survey data. Here we can use weighting as a way of pulling apart certain types of results. Now, here again, we're looking at the number of times the brand Arnold's was ordered. You can see it went from 1.5 to 1.8 in the last quarter, as we looked at before, and that's statistically significant.
But down here, we're looking at data on consumed in the last month, so the penetration data, and you can see it also went up. And so the question of interest is this 1.8 increase because people who are customers were eating more, or is it because more people bought the brand? So that classic frequency versus penetration argument. There are lots of ways you can answer that, but one way is to do weighting. And so what I'm going to do is I'm going to insert a new weight variable. I'm going to weight by my variable of Arnold's in the last month, and I'm going to set that at 6% as my target, because if you noticed really well the data I showed you before, you were seeing that 94% was the penetration over time, roughly. And I'm going to tell it to do the separate weighting for every quarter. And this is a cool feature because if you import new data, it will keep updating new quarters. But let's do it. So I've now created that weight variable, and I need to apply that weight to my two tables. Now, we can see the weight has worked on the table at the bottom because this is the one where we've actually used this variable as our target or adjustment variable. You can see that it's correctly showing 94% in every quarter, which is what the target. We can also see that we've still got this 0.3 difference here, but it's no longer statistically significant. So suggests that the biggest effect that driving it probably was an increase in usage in terms of significance, or penetration, I should say, but the frequency, it does actually seem to have gone up, but not statistically significantly. Tracking can be boring. We want to automate as much as we can. I'm going to walk you through some advanced tools for automating trackers now. I have here a survey, and many of you have seen this survey before. And this survey is showing me the data on phone market, US phone market. I've got a question in it, which is what did you dislike about your phone company? And I've manually coded 890 respondents into these categories. With the tracker, what we want to do is we want to set up automatic coding so that ideally, future weeks, we don't have to manually code. I'm going to show you how to do that. First thing we need to do is we need to go into text analysis, automatic categorization, unstructured text. And we're going to drag across our dislikes data. And here are the variables that I created when I did my coding. I drag them across as well. And that is going to cause Displayr to build a really cool little machine learning model trying to predict my categorization. Now, this takes about 4 or 5 minutes to run, so you'll be happy to know I've done it before. Let's zoom in and have a look at the key bit of the result, which is this table at the bottom. And this table is showing us how accurate the model will be at categorizing new text data. And the way it's worked is we had 890 respondents in total, but it's just built a model using only 200 respondents and seen how accurate it is at predicting the other 690. And it's doing this as a way of telling us how likely this model is going to be good to predict in new samples. And you can see the accuracy is 96.4%, which sounds really good, but accuracy is not the best metric. The best metric to use is this thing called kappa, and a score of above 0.8 usually tells us we're pretty happy. So this means that the automatic categorization is going to work here, which is great. I'll apply it in a second, but let's look at some other pages. I talked about this one in the previous advanced webinar on data cleaning before. What we're doing here is we've got a cross tab looking at age by week. And we're just looking to see if there are any significant differences. And if there are, it'll give me an error, and there aren't. And it's very pro forma code. You can just copy and paste it and reuse it in any project. And we'll send you a link to this document as well. And so again, we're looking now at race, and you can see again, nothing significant there, nothing to worry about in the first 4 weeks of data. And lastly, I've got this pretty page called brand, which is just showing kind of key results. And you can see here that my score for AT&T is 31, and it's a net promoter score. And you can see I've got 4 weeks of data. So now we're going to update this data file. And I've got a new data file with an additional 8 weeks of data. And some of you will have seen this updating process before. So 31's our old Net Promoter Score. We're keen to see what that will update to, which we'll see when the hourglass is finished. So it's moved up to 34. We're now looking at our trend data over time. You can see it's got 12 weeks of data. Now, to update other pages, we need to click on them. Displayr won't update the entirety of the document automatically, because if it did, it would just glug to a halt, as it had to run heaps of analyses. So it's updating the cross-tab on age. It's add the columns, nothing significant. I've got no error. We click on race, it updates the cross-tab, and we do have an error. It's hard to miss now, isn't it? Race is fluctuating heavily. And what's going on here is in week 8 in our data, we end up with a big spike in the number of Hispanics. And so this tells us that we need to investigate our sampling processes perhaps, and maybe we need to wait if we believe that that Hispanic subgroup has got different responses or different preferences in the rest of our survey. Now, the key thing we want to do though is update our automatic categorization. This is going to take 5 or so minutes to rebuild that model. So we're going to wait while it does that. Don't worry, we're not really going to wait. We're going to go back to the main body of the tracking. Now, the only thing which we haven't talked about so far now is email alerts, and check out our help pages for how you can use Displayr. It takes a couple lines of code to send email alerts in continuous trackers when key results have changed. So we've looked at how we can efficiently work out what's changed. Now we move on to how we can explain changes. I've got a really cool little framework for you here. Any metric that changes, and as an example, we had the change in the average purchase frequency of Arnold's from 1.8 to, sorry, from 1.5 to 1.8, which is a change of 0.3. That change can be broken down, decomposed, to use the jargon, into a series of sub-changes. One will be, and if we're just looking at gender for the moment, we can look at how did our frequency change amongst men. We can look at how did the frequency change amongst women. And we can also look at how did the proportion of our sample that was male change. And the reason that's important is if male's consumption is different to female's consumption, then simply changing the proportion of males in the sample can lead to a change in our overall metric. And we also look at changing the percentage of females in the sample. So these 4 submetrics will add up to this overall change. But if we calculate them, it'll give us a bit of insight to understand what's causing the change in the metric. Now, I'm going to show you a really cool way to automate it, but I am first just going to do it manually. So we create a crosstab, we drag across gender, we drag across our quarter variable, and we've got no significant differences. So we do have some little changes in gender, 50 to 48, but not statistically significant. Now we need to look at change in consumption within gender, within quarter. And that's a little more complicated to create. We're going to firstly find our variable, which is Arnold's, and we're going to need to create some new filtered variables. And we're going to, you can do this in Q as well. It's got the same name. Filter one variable set by another. So we're going to filter Arnold's. We're going to filter it by gender. Oops. And some new variables appear. And we just need to cross-tab them by our quarterly data. Now notice a few things here. We are actually seeing no significant differences in the last quarter, but we are seeing actual differences. So female consumption did go up from 1.4 to 1.8, and males went up from 1.6 to 1.8, but they're not statistically significant differences, but there is still some movement there. Now, be a painful process to do that for all of our demographics, wouldn't it? So fortunately, the data science team have built this awesome little tool called, I'll show you, it's hidden at the moment. It's hidden, you've got to go visualization, exotic, change explorer prototype. And the word prototype is there because we've figured out that it's some especially cool statistical tests we need to invent to make this super awesome. And we haven't done them yet. We've just kind of got some standard tests in at the moment. Just when I say standard tests, exactly the normal tests you use in a crosstab. So I'm going to drag across my Arnold's variable. That's what I want to predict. I'm going to look at it over time. So I'll drag across my quarter variable. And I'm going to look at it by age, gender, and location. And I'm also going to put in a work status. Now I need to tell it which quarters I wish to compare. So at the bottom of this, I've got some various options for doing this, and I'm going to tell her that I want to, so that my original quarter will be previous quarter, which starts in March and goes through to June 30. And then I will compare that with my newer quarter, which is July 1 through to the end of September. And now it's going to chunk away, is that a word? Anyway, it's going to do something, and it's going to calculate all of those little things that I calculated by hand before. All right, now, how do we read this? We've got things in color are telling us where there are statistically significant explanations. And the first one, the biggest circle here is for work status, student not working. If I hover over it, it shows me that 20% of my sample were students not working, and their increase in Arnold's consumption was 0.86. Now remember, the overall increase was only 0.3. So there is clearly one subgroup whose consumption jumped a lot. Now, if we multiply these two numbers together, we get the contribution, which is 0.17. And we should multiply them together. Now, remember, our overall change in Arnold's consumption was only 0.3. So we can explain more than half of it, that is 0.17, just with respect to this one group of students. So we really have very quickly identified the key subgroups whose movement seems to have occurred. We've got another little group down here showing unemployed people. It's a much smaller group. It's only 2% of the population. Their mean consumption dropped quite a lot, 1.23, and it is statistically significant. But because it's such a small group, its contribution is pretty small as well. Now, I want to draw your attention to the fact that the size of these circles is proportional to their contribution. And a big circle here is approximately a contribution of 0.2. And you'll remember that 0.3 is the total amount we're trying to explain. Now, this visualization is looking at the effect of changes in the averages within subgroups. This one here will look at the effect of changes in subgroup size, which remember is the other set of explanations for why numbers move. And we can see here that work status unemployed is significant. And if we hover over it, it tells us that this group declined in size by about 3%, but the contribution's effectively zero. And take note of the legend here. Remember before a big circle was 0.2, now a big circle is 0.01. And this is telling us that there is a significant effect due to change in group size, but it's so small that we don't really care. The other aspect to explaining change is to create deep dives, ways of entertaining your audience. I like to do things that focus on the laws of the market. So I'm going to take you through some of the things I used to present when I did tracking research back in the day. These were all targeted on the third presentation onwards, when people had started to get a bit bored with the numbers. It's an oldie but a goodie, and I'm sure lots of you do this, which is just simply to look at some purchase hierarchy or decision flow or some kind to create sequences of brand health, create the table and compute the conversion and try and interpret and look for insight there. Now, what's often interesting, particularly when you've got a lot of brands, is to just plot two of those dimensions on a scatter plot. And you'll tend to find there will be a pattern. It's almost always a pattern. It's so common there's a pattern, there's a name for it, and that name is double jeopardy. Now, here I'm doing the most famous pair of metrics to compare when we're assessing double jeopardy, which is penetration by frequency amongst people who have purchased the brand. And you can see here, Arnold's wins in terms of eaten the last month penetration. Arnold's wins in terms of frequency, and that's true in just about all markets. The brand that's strongest on penetration tends to be strongest on frequency. But where this gets interesting is you draw the line through and you notice deviations. And you look at Burger Chef, for example, and you can say, well, sure, its consumption frequency and penetration is much lower than Arnold's, but its actual frequency of consumption is relatively high given its penetration. So that's good. It suggests that it is appealing to a niche or a niche of customers. You can get lots of different shapes for the double Jeopardy, and the shapes give you insights. For example, in the bottom right-hand corner shows an exponential relationship, and this is what you see in a winner-takes-all market, such as commonly occurs, for example, with social products, where if you're strong on one measure, you just dominate on some other measure. Another favorite way of entertaining the audiences for me in tracking presentations when we were running out of interesting movements was the basic brand vulnerability matrix. Here we contrast usage with attitude, and the two bits that are most interesting are the group of people who don't like our brand but still buy it, and the group of people who like us but don't buy it. Here we're again looking at our good friend, the brand Arnold's, and we're seeing here, we've got this top segment here, which is showing us that it's 4% of the market, but 11% of our share are people that buy us, that visit us twice in the last month, despite not liking us. And we can see here that's been driven by convenience, so breakfast, late night snacks. So presumably this Arnold's brand's got a better distribution than a lot of the other brands. And that's also, though, you remember, in line with, we saw that over the last 6 months, they'd improved a lot of their out-of-home perceptions as well. Another classic to do is market maps. Most people love a market map. Some people love importance, performance, or quad maps, where you contrast the importance of attributes, maybe from a driver analysis, with perceptions of performance. Here's one for Coca-Cola. Now, for each of those frameworks I've taken you through, we've got resources, ebooks, and webinars, which give you more detail on how you can calculate them for yourselves. Let us see how our automatic tracking's going. All right, we've updated, have we? Cool. So let's now create a cross tab. I'm going to select, whoops, I'm going to save out my variables. So go to the bottom, categories. So I've now saved my freshly auto-coded variables out. I'm going to drag them onto the page. And I'm going to drag across my interview date. Remember, we did our manual coding with 6 weeks of data, but we've now got 12 weeks of data. So we have successfully automatically coded the data. But we've got some significant things we need to worry about here. Now, normally, we'd be wanting to see significance variation, like maybe price went up or something in one of our weeks if something had happened there. We don't see that, which is fine. But what we do see, most concerningly, is at the bottom row, we can see the net, and we can actually see we do have a net that's less than 100% for most of our weeks. And what this is telling us is that there were themes in the newer data that weren't in the data we used to build the models. So we're going to have to go back and look at that coding again to see if there's some additional categories we need to add into it. And the way we do that is we just filter the data, look at those raw responses, and see if we need to categorize them. All right. We will send you a recording with any follow-up material. And we'll include the previous webinar and the follow-up material from that previous webinar. Anyway, look, thank you all for participating and joining the webinar. All of our customers out there, thank you so much for being our customers. Bye now.